All right, hey guys. So today we're going to cover lessons 6 and 7. Uh, I'm Ted. I'm the backup for today. So we've had a few lessons where we said, okay, there's the basic structure for writing a query to pull data out of a database. It's going to be select and then the columns that you want from the name of the table that they're coming from, and then you optionally, normally, will have a where clause that has some type of criteria. So you might want only one row, so where you say where customer ID equals 1, 2, 3, 4, or you might have some combination of logic. You might say where order date is less than this date and such and whatever, like that. So in lesson 6, what we're adding now is a new option for your where clause, a new option for filtering. So we saw you can use equals, less than, and so today what we're talking about is the like operator. All right. And so the like is used for matching patterns in strings. And so here's an example here. We're going to use this percent sign, and the percent will match anything. Could be 0 characters, could be 1 character, could be 100 characters, and it doesn't matter what the character is. Okay, just so you know, this is not full regular expression capability. It just has a few wildcard options. All right, so if you look here, select the prod ID, the prod name from the products table, where the product name like fish percent. So this is a way you can do a prefix. And so this will find any product that begins with FISH. If you happen to be in a case sensitive database, or sometimes it's not database specific, but it's actually, it's sometimes not vendor specific, but rather it's database specific setting, then it'll have to be a product that begins with capital FISH. If you're in a non-case sensitive environment, it'll match to any mix of capital, all uppercase, lowercase, whatever. All right. So this is a pretty common format, and the performance on this is not too bad because basically, right, if the database scans through the product names, it can look for the first few letters and see if it matches. If the first few letters match FISH, then it keeps the row. If not, it tosses it. All right. If you don't want to just match for any number of characters, we've got our underscore wildcard. And that matches exactly 1 character. It can be any character. So in this one, you see select the same things from products where product name like underscore space inch teddy bear. All right. So this will match any 2-digit teddy bear. I believe in the sample data, there's like a 14 and a 16 inch. But if you have a 9-inch teddy bear and it's 1 character, then it will not match that, okay? Because it's literally looking for 2 characters. And of course, SQL Server doesn't know what makes sense. So maybe you're looking for a number here, but if it somehow says XX inch teddy bear or anything like that, as long as it's exactly 2 characters, then it'll match. I talked about case. The other thing is, when it comes to Unicode, there's like even sort of, more varieties of things in terms of like a vowel could have diacritical marks, accents, umlauts, whatever. And so again, you need to check with your database to see what the settings are. Just so you know, I'm used to working with Microsoft SQL Server. The default for that is that it's not case sensitive, and it is not sensitive to diacritical marks. So if you said fish percentage, it would match to all lowercase, it would match to all uppercase, it would match if the I has an accent on it. It'll match any of those things by default. Again, depending on the vendor, different database systems may have different defaults, but anytime you're working with strings in any language, whether it's a database or whether it's Python, R, whatever, you do need to be careful about these, string, dependencies. And then finally, the last option we're going to talk about is inside square brackets, you can list a set of characters that are valid. So here's an example where you say, I'm selecting customer contact from customers where the customer contact is like, and then in square brackets, we have a J and an M. And then we have a percent wildcard, meaning anything after that. So this will match any string that begins with J, whether it's one letter J or whether it's longer than that, and any string that begins with M, whether it's one letter capital M or it's longer than that. If you wanted, you could use more of these square brackets. You're allowed to use more than one in your like expression. So you could have JM in square brackets, and then let's say you could have, AE in square brackets. And so then it'll match anything beginning with JA, JE, MA, ME, and so on and so forth. So generally speaking, using like is not the fastest thing in the world, but it's not like you need to be afraid of using it if it's appropriate to use it, especially if you don't have some absolutely ginormous database. If you've got 10 billion rows, well then, you may want to worry about it a little bit. And I believe, if I remember right, there was a note in the chapter that says if you start your like expression with something like a percent, then that can be kind of slow because it's going to take it a little while to check each row. Since if you said like percent fish percent, then it's looking for fish anywhere in the string, and that's going to take a lot longer than looking at the first 4 characters and seeing if they're exactly FISH, even with the whole like casing and all that other kind of junk. All right, so that's like, so we now have in, and we have like equals, less than, things like that. We add like to it. You can and, or, not, any number of these things combined. So you can say whatever, order date is less than September 1 and whatever, item like underscore inch teddy bear and blah, 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 whatever. You can, if you have a valid something in a where clause, then basically you can have as many of them you want. You can use them however you want with ands, ors, whatever you feel like. All right, so that's the quick summary on lesson 6. Questions, comments, thoughts?
Yeah, I think I noticed that Oracle SQL was a bit case sensitive.
It might be. I've used Oracle like twice. I think it might default to case sensitive. Yeah. Again, anything, whether you're using pandas in Python or whatever, you just need to like double check whether things are case sensitive or not if you're gonna do any kind of string comparison. Whether it begins with, contains, anything, you just need to know, how it's going to treat that.
I may missed it, but does it allow to go through whole alphabet in the square brackets when we do something like A-Z, like it is in Python or R?
Yeah, I do not believe you can use dash. You have to literally list them all out. Like I said, this is not a regular expression, full-fledged thing. It's just some pretty basic wildcards.
Thanks.
Yeah.
Ted, I think you might have asked this before, answered this beforehand. What SQL language do you typically use?
So me personally, all of my experience has been with Microsoft SQL Server.
Okay.
So that flavor is sometimes known as Transact SQL. And then I've been using it long enough that it has evolved over the years. So over the last 25 years, there's a few things that they have added support for. There's actually a few things that they've dropped support for.
Okay, thank you.
Yep, yeah. And everything that's like core in the book is usually going to be common to all of the different database systems. What we'll see in the next section is that occasionally you have some slight differences in syntax, next section, we concatenate strings. And there's a different command for it on different systems, but they all support concatenating strings.
Around for that case sensitive, other than system setup.
I'm sorry, I missed the very beginning of
Oh,
your question. Your
Sorry,
volume's
do you
not there.
know of any other workaround for that case sensitivity issue? Like, would we be able to have two, like, with a,
Option.
yeah,
Yeah, so we haven't talked about it. I believe explicitly it's in like chapter 8, okay? But you can do things like almost every system I know has like a 2 upper and a 2 lower command, okay? So if I converted my string to lower and I compared it to FISH, then it doesn't matter whether the original string had capitals in it or all caps or whatever. Once I do 2 lower, it's going to match, you know, FISH. I will say you still need to be careful if you're dealing with non-English in terms of accents and diacritical marks and things like that. There's even like weird stuff in Unicode about like what matches a space. So, you know, if you get really hairy, then there's unfortunately there's gory details. But it's a pretty common thing to see people run 2 upper or 2 lower before processing strings. If you just don't care about case sensitivity. Did that answer your question?
yes, thank you. I was just curious. There was a
All right, great.
way to look at that. Thanks.
Sorry, I can't tell if you had a follow-up. Just for whatever reason, your mic's
Sorry,
in and out.
I'm in a really bad area right now.
Okay.
Yeah, no, definitely that answers the question. Thank you. I was just curious.
Yep. All right, anybody else? Any other questions? All right, let's talk about lesson 7 then. So creating calculated fields. So we've had a couple lessons where we're just adding to our tool belt for what we can stick in the where clause. All right, this is now a slightly different thing to think about. The author is going to talk about this by introducing the concept of calculated fields in the list of things that you're selecting. So the author says sometimes you want the data formatted differently than how it literally is stored in the table. All right. And so SQL very much has the ability to create new calculated fields on the fly. So the example they give is, let's say you have a column that has the name of the vendor and a column that has the country. Well, if you want, you can concatenate these together, and you can even add your own literal things like spaces, parentheses, whatever. And so here you can see I've actually concatenated 4 strings together. One is a column, the name of the vendor. One is just a hard-coded literal string, the parentheses. One is another column, and then another hard-coded literal close parentheses. All right. I'm used to Microsoft SQL Server, which uses the plus sign. In the book, they say, hey, you might need the vertical bars. You might actually need a function to concatenate things. But small syntax differences aside, the key thing here is up till now, the first few lessons, the only thing you've seen in the select is a column name separated by different column names separated by commas. All right. And so now basically the chapter doesn't really talk about this, but I'm just going to say basically any place where you can have the name of a column, you can have a complex expression. So you can concatenate strings, assuming that the system allows it. If that string actually contains a number, you can convert the string to an actual number. You can square it. You can add 1. You can divide by 10. You can then convert it back to a string. You can convert that string to a date. You can take substrings. basically anything that your system supports that allows you to do, any place you could have a column name, you can have a very complex expression instead of just a simple column name. Okay, so we see here concatenation, pretty common. I do that pretty often, like first name concatenated with last name. They show here using a function. And so in this case, the rtrim function will take off any extra spaces after the last normal non-space character, non-white space character. In the book, this first one you see, it actually has vendor name and then like there'll be like 10 spaces before the open paren, just because that's how it was stored. And so this will strip off all the extra spaces. And so because it got rid of all the spaces, actually, there is a little space here in front of the parenthesis. Otherwise, the parenthesis would be jammed up right next to the name of the vendor. Okay. You can do that. And then the other thing that you can do is you can say what column name, as it were, you want to give this particular calculated field. It's not going to have a default name because it's not literally just a particular column coming out of a table. Generally speaking, I would say I recommend that you name calculated expressions that you're returning. Even when I do really, really simple things like, hey, I just want to count the number of rows in a table, just out of habit, I will just throw like as n. And so it's not the most meaningful title, you know, it's not saying num of whatever, number of vendors or whatever, but it's still infinitely better than just unnamed column. So I can't remember if the author recommends that, but it's just a really good habit to get into. Give it some kind of name, even if it's not the most meaningful name. And then the author shows that you can also do mathematical calculations. So the usual things that you would expect, plus, minus, times, divide. I'm pretty sure there's a way you can do exponents in Microsoft SQL Server. And then there's probably a library of some other common functions like log, and I don't know if it has like sine and cosine, but it wouldn't surprise me. Nope, it doesn't really take much just to, you know, give you a library of a couple dozen common, you know, mathematical functions. So again, if a column name is valid, then you can have quantity times item price. There's no reason. And if I wanted to, I could do this quantity times item price divided by 100 if I felt like it. And I could do whatever other, you know, kinds of things. I mean, over the years, I'm sure I've done a bunch of things. Microsoft SQL Server has functions that will do things like ceiling and floor. So if I want, I can round this number off to the nearest whole number. I'm sure I've done that a fair number of times. Let me just sort of stop here in terms of like what you can, you know, can't do, and just pause and see if there's any, again, any comments, questions, thoughts about expanding from single column names now to generally, you know, the kinds of expressions that you're used to in any programming language. Okay. So I'm going to add
I have a question, Ted. Sorry.
Oh yeah, please.
I wasn't finding the unmute button.
Oh yeah, I've been there.
I guess my question is more kind of general. In what case will we prefer to do that kind of transformation of the variables in SQL instead of just querying the data and then exporting for something like Python and, you know, playing with the data in Python? Like, in what case is more efficient if you want just use it in SQL instead of using a programming language? In my case, I'm more familiar with Python, right?
Yeah.
And in some cases, I feel like it's less cumbersome even to use another sort of language than SQL.
Mm-hmm. No, that's a really good question. So where do people usually put the logic? I'll give you two rules of thumb, okay? So one is if if there's a convention in your organization, whether it's a team or whether it's a company or whatever, certainly I would follow the convention. Okay, there's no reason to, computers are pretty fast, so you can do it in either place. Okay, what I would say is that if there isn't a convention, there is the tendency to do things like mathematical calculations in the database. Okay. Generally speaking, when you run a query, you're running it on a really giant honkin' server. And that server can often do things like quantity times price very, very fast, faster than your laptop. So if you add this quantity times price to a database query, it may slow down that query by 1 millisecond. If you try and calculate quantity times price in a pandas data frame, it might actually take you a second or two. So, I mean, not the end of the world, but so the tendency is to do things like that. If it's something like I have a date and I want to format it in a particular way, that often is considered sort of the user interface. And so you tend not to do those things in the database. I've certainly broken that rule, but I'm just saying things that are sort of like not calculations, but just appearance. You tend to just say, okay, database, return me the full data, and I will decide how to format it, how to display it. It's even possible that you might have a query that returns 5 columns, and in the end, you only show 4 of them to the user. That certainly happens. Things like that. So that's sort of my high-level answer. Does that answer your question?
I see. Yeah, that makes a lot of sense. Thanks.
Yeah. And then I'll also say that then once you get into ginormous queries, so you're querying, something with hundreds of millions of rows or something like that. If it's something that sort of affects the logic, the performance of the query, like if you say, well, I only want the rows where quantity times item price is over $100, then absolutely I would do that on the server, because it's going to reduce the number of rows coming back. Okay. As opposed to sending extra rows back to my laptop and then reducing the number of rows there. Again, if you're just playing around and it's small data, you're free to do it whichever way you want. But generally speaking, that would be the other rule is if you can send less data back to your laptop. And by the way, like I've done stuff where I have queries that return like 100 million rows, and it takes over an hour to send that data to my laptop. So like, no, I don't want to send any extra rows. If I can actually help it, I will minimize the amount of data just going over the wire to my laptop. All right, great. Yeah, Brett, I see you have your hand raised.
Quick question. I do a lot of this kind of stuff with fetches with JavaScript, and I'm wondering if it's possible, in your knowledge, to do the aliases and performing mathematical calculations inside of API requests with JavaScript. I know that's kind of a side question, but maybe you might have an answer to that.
Are you doing a database query?
Yes, sir.
When you say fetches? Was that a yes?
That is a yes.
Yeah, okay. So if you're actually doing a SQL query, you should be able to rename things, and you should be able to say as expanded price, wherever it's from, whether it's from Python, R, JavaScript, you name it. Okay. And then that will give you a more convenient or clearer name or whatever. I believe in the chapter, the author even mentions that if you are dealing with a database system that for some reason, let's say they had expanded space price as the name of the column, that is just really inconvenient to work with. It's really inconvenient in R, it's really inconvenient in Python, it's actually really inconvenient in SQL Server to deal with columns that have spaces in them. You always have to have some kind of delimiters, whether it's square brackets or backticks or whatever. And so, yeah, first chance I get, I rename that sucker something that doesn't have a space in it. So, I don't know exactly, what you're using, but if you're running SQL, then yes, you should be able to rename anything that you want.
What about doing a query from R or Python? I mean, both R and Python have, well, packages, modules, which allows to connect with a database and write a query inside some kind of command.
Mhm.
So the query will be done in SQL, right? And then the data will be transferred to R or Python.
Yep.
Yes.
Yes. And so if you include something like as expanded price, then when you get your 4 columns back, the 4th column will just be called expanded price. And that'll work perfectly fine.
Mhm.
Yep. By the way, that reminds me, so week 1, I showed a small Jupyter script if you want to, from Python, query SQLite. So the link to that is in our book club repo. So if you go and you look for session 1, so the author has sample database files on their book page for different database systems. And then I used the SQLite one to create a tiny little Jupyter notebook. And so you can see here where I said select star from customers. But I could have said like select customer ID as ID, and then that would have renamed this column. Instead of cust ID, it would just be called ID. And I cannot imagine any scenario where any SQL engine would not support that. All right, any other questions?
Yeah, I've got a question. I'm always kind of intrigued by when you say like what goes on behind the scenes, because I know SQL is kind of weird in the order that it runs your code. So I'm curious as to like going back to the earlier lesson with the percentage sign.
Mhm.
I'm assuming we probably want to filter out the data before we run that percent sign wildcard search. Is that accurate?
Yeah, so the focus of this series is really to get people up to speed so you can write SQL. I'm hoping that like if you are going to be writing production code SQL queries, maybe spend a little bit more time learning about databases and some of the ins and out. If you just need to get yourself a data set because you're doing some project in Python, odds are it really doesn't matter. If you write the worst SQL in the world, maybe it'll run 3 times as long as if you write the best SQL in the world. If that's a difference of a few seconds, the reality is it'll take you more than those seconds just to figure out how to tune your query to make it better. So, again, if you're not dealing with like billions of rows or production code, I think it's okay. You don't need to know. I'm happy to share sort of, the ins and outs. The thing that's different about SQL databases, so going back to lesson 1, so this is a declarative language. You are defining the set of rows and columns / expressions that you want. You are not actually telling SQL Server how to do it. Any database system, whether it's Microsoft SQL Server, Oracle, or even if it's not even a relational database, but it supports a SQL interface, it is because there are interfaces that will like use SQL that let you query an Excel spreadsheet or whatever. It's going to decide how it wants to do the query. For modern relational database systems like Oracle, Microsoft SQL Server, DB2, whatever, they have pretty smart query optimizers that will sort of look at a number of different options and decide on a very good, very reasonable way of pulling the data. And so in that sense, Harold, it may not be intuitive to you the order in which it is pulling things, because again, there is no order in what you're specifying. You know, if I say I want product ID and product name, where the name is like blank blank inch teddy bear, theoretically, I mean, this might seem completely unintuitive to you, but theoretically, the database system may go through just the product names, and it'll find all the matches, and it'll say row 71 and row 1000 match that rule. And then it'll go back and fetch the product IDs for those two rows. Might do it that way. It might do it a completely different way. It might collect the whole row so that by the time it found that the name matched blank blank inch teddy bear, it already had both those things, you know, sitting there right in memory. So if you don't know all the ins and outs and all these details, it may seem surprising to you how it chooses to do it. And so that's something that as a beginner, like, I would not assume to know exactly what it's going to do. But the bottom line is, it is going to do something pretty reasonable. And until we get to very complicated queries, it's pretty much impossible for you to write a query that will perform poorly if it's correctly written. So the order in which you type things and this and that, and for example, if I say, oh, the date is between August 1 and September 1, or if I switch that query to say the date is greater than or equal to August 1 and the date is less than or equal to September 1, instead of using between, the performance difference will either be 0 or it'll be so tiny it's irrelevant. You know, it'll be less than a millisecond difference in performance. So I hope that helped answer your question.
Yeah, I took a SQL crash course a long time ago, and they explained that the order, I guess, that it looks at your query is like it looks at the database, like the line where you have from first, and then where, and then it only gets to the select part at the very end.
Well, I mean, yeah, I mean, we could talk about that a little bit, but at the end of the day, like a basic query has to have a select and a from and a where. So which order it looks at them, that will affect possibly things like if you have a syntax error, which syntax error shows up first. But at the end of the day, it's going to look at all three of them. And so I don't know how important it is to know exactly, you know, there's like old stuff, like 20-year-old advice. We haven't gotten to it, but if you're pulling data from multiple tables and you're joining it, it used to matter how you listed that information, okay? But I can say for Microsoft SQL Server, that absolutely doesn't matter. It's going to try approximately 100, 200 optimizations in a few milliseconds. And it's going to consider many different ways that it could hit those tables. It doesn't matter what order you list them.
Yeah.
Not anymore.
Okay.
You know, I took a course on BigQuery on Kaggle, actually, and they said that it matters, and BigQuery works actually on clusters. So they said that it is a huge data set, and they in particular use this example with join. If you do something like Cartesian join, then it is better to filter tables first and then do the join.
It's possible that the optimizer isn't as good for BigQuery, not yet, or not at the time that they wrote that. It's also possible that you might write your query in a way that it doesn't quite understand that it could do the filtering earlier. But I can assure you that if it was something very simple, like in this we have, I think, an order table and an order items table, okay, and you just join those two. If you said, and again, we haven't talked about joins yet, but I want to know information about the orders and the order items, where the order item meets a certain criteria. I know that the SQL Server Optimizer will absolutely limit the rows in the items before doing the join. It will not wait until after. And it doesn't
Wow.
matter how you write the syntax, it will always do that because it'll figure out that that's faster.
Oh, this is good.
Yes. Yeah. So the databases have gotten smarter. All right. I'm going to throw in two other color notes here. These are not really important, but just, these are things again that pop up in any programming language. So if we do something like quantity times item price, well, if quantity is, say, an integer and item price is a money, a floating point, a decimal, something like that, but it could be like 1999, right? Then intuitively, you and I look at this, we say, well, the result of this probably should be some kind of decimal or floating point result. And so again, my experiences with SQL Server, it absolutely kind of knows this, like, the hierarchy of data types and things like that. So you will see that it will sort of like automatically cast things to like the more flexible data type. And so this result will come back as like a decimal or a floating point type thing. That's kind of something you need to deal with a little bit in any language. I, for whatever reason, seem to very often run into this issue where I'm sort of manually calculating some type of average. So I am dividing the somethings by the number of things. And if the somethings and the number of things are both integers, then even though I use division, this is not like Python, SQL Server will keep things as integers and will give me an integer answer, which is very annoying when the answer is like, say, a number between 0 and 1. And so then I have to actually force things to floating point first. There's the proper way to do it. And then like the cheat way I do it is I take a floating point number and I say 1.0 times blah, 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 blah. And then that causes the auto, type conversion to kick in and everything becomes the more flexible floating point. That's probably not like what you're supposed to do in production code. You're supposed to more formally say, please convert to floating point. But I just want to give one note that that's something that can trip you up where, for example, you do something divided by something and everything just comes out 0 because it's doing integer division.
Sorry, Maya, were you going to say something?
I thought Python 2 did the same. And now in Python 3, they changed it. If you use that usual division sign, that the result won't be integer division.
Yeah. So in Python now, if you say 1 divided by 100, you get 0.01. In SQL Server, if you say 1 divided by 100, you get integer 0.
So Ted, is that just something that we'll have to keep in mind for dividing with integers, or are there other situations we should keep that in mind for?
Again, I would say in any programming language, you kind of need to keep track of your types and be a little bit aware, right? But I just thought I'd mention this since I don't know, it seems to me like half the time when I write a query, I'm doing division and I need to insert this little cheat, or I need to formally cast my answer as a floating point answer. Otherwise, I get integer division, which usually isn't what I want.
Thank you.
So I just thought I'd mention it since it comes up for me all the time. All right. So the other thing I'm going to mention, which I've already sort of said it, but I'm just going to repeat it more explicitly, is this chapter, this lesson 7, only talks about putting expressions like quantity times item price in the select fields, okay? But I'm just letting you know, any place where you could have a column name, you can use an expression instead, okay? And so I could say, oops, I could say, and, nope, and quantity times item price. is greater than 100. Okay. So far, we've only seen things where it was like a single column where it would say quantity is greater than 100. All right. I'm just letting you know, any place where you could put a simple column, you can also put expressions. And later on in the book, I think we might see you can have some fairly complex expressions. It's not pretty, but you can even have things like case statements where it's like, you can have ifs, or you can have like case type statements where you can have like, multiple whens and things like that. But you might not want to do it if it's kind of ugly looking, but the bottom line is it is valid for you to put an expression basically any place where you can have a column. It doesn't have to be a column. It can just be any expression that uses a combination of columns and literals. Because at the end of the day,
sorry, in this example that you just gave, would we be able to use the alias even though that query hasn't run?
So there was something the author said about like using the alias. I never use the alias. Sometimes I wish I could, but I don't think Microsoft supports that. So here, if I wanted to say like, and expanded price, right? It's greater than 100.
Yeah.
That might work on something else, but Microsoft SQL Server, that won't work. I don't think I can use expanded price basically anywhere. I can't use it in the sorting order by clause. I can't use it anywhere. And who knows, maybe there's like new support for this or some other database systems, but basically, no. I would repeat, I would copy paste and repeat like that expression over again.
Got it, thanks.
And in fact, one of the things that I hate about SQL is sometimes I'll have a complex query and I'll have this quantity times item price like 7 times repeated in there. And from a programming perspective, it's easy to make a mistake. I could have a copy paste mistake. And it's also just less obvious to someone reading my code that all of these are supposed to be the same thing. So I wish I could use expanded price, but no. And SQL has its origins. It's a very old language. So unfortunately, that's not something that anybody thought was important enough to change the standard. And so, again, maybe there's another system that supports it, but for me, yeah, I do a lot of pasting over and over and over again. Good question. All right. So again, those were just 2 like little things I thought I would add on just because we got a little bit of time. So, all right. Any other questions on this material? All right, great. So I'm going to stop the recording here. This will be the official end. I can remember how.